Here we go. Okay. So just like in our journal, we talked about identity. We use the word identity because they look what? They look identical. That's when you have a true number statement. We said in our journal that's when you have a true number statement, like 4 equals 4. We also said that you have the same exact variable term and the exact same constants because they look identical. That's why it's called the identity. So question number 1 says, which equation is an identity? Which equation has the same binomial? I'm going to write that out because I think that's really important. Same binomial on each side of the equal sign. Same binomial on each side of the equal sign. Ma'am. Number 2. Are those the same? You see that you have actually a positive 9 and a negative 9. But I'm glad you said that. Those are not the same. Okay. Someone else. Tim. 3. Let's see. I have a negative 6m, a negative 6m. I have a negative 12 and a negative 12. Yes. Number 3. Exactly the same. Watch for that. Watch for that. That's tricky, right? They have to be not just the same number, but it has to have the same sign in front of it. Remember that the sign is included with the number. Question number 2 says, which equation is inconsistent? So I want to talk about what inconsistent means because we wrote this in our journal. This is just kind of a reminder. So we said inconsistent. That means what? It means you're going to have no solution. Go ahead. What else does that mean?
Solution and equations on either side of the equal sign are not exactly the same.
Yeah, they're not the same. You get a false number statement. Do you guys remember that? So you end up with something like negative 2 equals 7. And we know that that's not true. So remember we said that we know that they have to have the same variable term, but they have different what? You can look at your journal. If it's inconsistent, it has the same variable term, but different what? We wrote that word in our journal. Same variable term, but different.
Signs.
Tim.
Different constants.
Different constants. Good job. Different constants. Perfect. Okay, so let's see. Same variable term. Same variable term. Are the constants the same or are they different? Different. So this one is inconsistent. Let's look at this next one. Same variable term, same variable term, same constant, same constant. What's this one going to be? What's this one going to be? This one's going to be an infinitely many, right? What about this next one? Do we have the same variable terms? Are those the same? Yes or no? Is 3c the same thing as negative 3c? No. So when we have different variable terms, we know that we're going to have only one solution. Only one solution. When I look at example number 4, different variable terms, that means that this is going to have exactly one solution. Remember, if it has one solution, the constants aren't important. It's the variable terms. So the only one here that is inconsistent is example number 1. The only one that is inconsistent is example number 1. Inconsistent means no solution. Question number 3 is a not question, and these always mess up my brain. I have to read it a couple of times. So which equation does not have an infinite number of solutions? So that means that it could either have no solution or it could have one solution. That's what we're looking for. We're looking for equations that have no solution or one solution. So notice that all of these have a what in them? What's going on with all of these equations, Owen? What do they have that we have to fix first?
Sorry, I don't know.
Sure you do. What do we have to do first to see if they look the same? Yeah, we have to distribute on every single one of them. Negative 5 times q is negative 5q. Negative 5 times 4 is a positive 20. And the other side doesn't change. Negative 5q equals, not equals, negative 5q minus 20. So let's distribute first for all of them, and then we'll go back and talk about each one. Is that okay? The second one, we're going to distribute 3w minus 15 equals 3w minus 15. The third one, when I distribute, I get negative 2h. Negative 2 times 4 is negative 8 equals negative 2h minus 8. The last one, when I distribute, 7a minus 42 equals 7a minus 42. So I'm going to go back to the very top. What do you notice about it? What kind of solution is this going to have? What's the same? What do they have on both sides? The same what?
They have the same variable.
They have the same variable term. Okay. What else do they have? Do they have the same constants? Is positive 20 the same as negative 20? No, they have different constants. So when we have the same variable and different constants, look at your journal under those special cases. Same variable, different constants means what?
No solution.
It means no solution. Good job. So this one is a no solution. What about the next one? What do you notice about this? Do I have the same variable term? Avery, do I have the exact same variable term on both sides? Okay. I can't hear your head rattle. What about the constants, Avery? Yes or no? Yes. So what does that mean when I have the exact same variable and exact same constant, Avery? Look at your journal that we just filled out. What happens when you have the exact same variable with the exact same constant under your special cases? Exact same variable, exact same constant. Look at your special cases. Are you in the journal that we just filled out today? Okay. Flip up the bottom, go to that journal, flip up that bottom piece where it says special cases, right? What does it say? So what did we write? We wrote that if something has infinitely many solutions, what do we know about it? If it has infinitely many solutions, they have and same variable term and same variable term and constant. Do those have the same variable term and constant? Yeah, so this is going to be infinitely many. Infinitely many. Next one. Lissandro, what can you tell me about example number 3? Example number 3 of question number 3. They're exact same. So what does that mean? Infinitely many. Thank you. Kenna, look at example number 4 of question number 3. What can you tell me about that? They're exactly the same. Same variable, same constant. What does that mean, Kenna? Infinitely many solutions, which is different than infinite. Okay. So the only one that doesn't have an infinite number of solutions is answer choice number 1. This is a homework sheet that I turned into our notes because I want you guys to be able to identify, right? We want to talk about what they look like. So which equation has exactly one solution? One solution. They're good. So only one solution. So let's distribute. So our first one has, when we distribute 2p minus 12 equals 2p minus 12. What kind of a solution is that going to give me? Infinitely many, because both sides are exactly the same. They look identical. That's why it's called an identity. Okay. What about on example number 2 of this question? When I distribute, I end up with 12k minus 30 equals 12k. I said k and wrote x. I'm so sorry. 12k plus 11. What do we know about this one? What is this going to give us? What? You think it's going to give us one solution? We have the same variable term, so those are going to cancel out, and we're going to end up with a statement that says, yeah, negative 30 does not equal 11. This is a no solution. Good job. This is a no solution. What about example number 3? Let's see. Example number 3, when I distribute, I end up with negative 8c minus 14 equals, let's see, negative 2 times 4 is negative 8, and negative 2 times 7 is negative 14. What can we say about this one? What do you think, Victoria? Infinitely many, exactly the same. Infinitely many solutions, exactly the same. Last one, let's see. When I distribute, I get negative 4n plus 12 equals 4n plus 12. Are the variable terms the same? No, the variable terms are different. Remember, when the variable terms are different, it doesn't matter what the constants are. If the variable terms are different, you're going to have one solution. And that's it. So the only one that has one solution is number 4. Example number 4. Do we have questions about that? Does it help to see them that way? Okay. For each of the following equations, manipulate one or both sides of the equation. Hang on a second. I'm going to do, I wrote down, I need to look at my journal. Look at our Canvas page really fast. We're only going to do 2 of these. I think that we're going to do A and B. We're going to do A and B. So I'm going to do the top 2 examples, okay? So let's see. What do I need to do first? I'm only going to do A and B. Kenna, you tell me. Which one do you want to do first? Okay. Absolutely. Nice use of the vocab terms. You have to distribute. So let's see. I have 3x plus 4 times x is 4x. 4 times negative 3 is negative 12 equals 9x. Negative 2 times x is negative 2x. And negative 2 times 6 is negative 12. What would you like to do next, ma'am? Combine like terms. Let's see. On the left side, I can group my x's together. So I have 7x minus 12 equals. And on the right side, I can group my x's together. And I have 7x minus 12. Huh? They're exactly the same. Do you guys see that both binomials are identical, which means that this has infinitely many solutions. It's called an identity because they're identical. And the reason that word identity is important because you're going to see that again when we start systems. And I want you to remember, if it's the identity, it just means that they're identical. Identity is identical. Come here. Go ahead and grab your stuff. Where are you going? Yes, thank you. I'll write you a pass. You do know better than that, right? Yeah. All right. Example B. What are we going to do? We're going to distribute. All righty. Negative 5a. Negative 4 times a is, yes, ma'am. Negative 4 times 6. Negative 24. And then on the right side, 3a. What is negative 3 times 4? Negative 12. So negative 12a plus 24. All right, let's see. We can combine our a's on the left and our a's on the right. Negative 5 and negative 4 give me negative 9. So I have negative 9a minus 24. Yes, ma'am. Equals. What about the right side? Positive 3, negative 12 give me. When the signs are different, you subtract. 12 minus 3 is negative 9 plus 24. Yeah, you subtract and then you keep the sign of the bigger number. So 12 minus 3 is 9. Keep the sign of the bigger number, which is negative. So what do you notice here? So different constants. So I'm going to write that. Different constants. That's all right. But you have the same variable. What does that mean? Different constant, same variable, Lissandra. Inconsistent. Awesome. I love it that you use that word, inconsistent. And what does that mean in terms of our solution? If it's inconsistent, do we have a solution? No, no solution. Perfect. You guys are awesome.